This is the second part in a group of videos showing how to set up a motion analysis on a Formula SAE car's suspension system using SolidWorks Motion. In order to run the simulation correctly, it is best to simplify the model by removing any parts that do not have to do with the suspension. When simplifying, make sure that the ends of the arms are located where they would be mounted on the rest of the frame. To start the motion study, add in SolidWorks Motion by going under Tools, Add-ins, and selecting SolidWorks Motion. To insert a new study, go under Insert and select New Motion Study. This will open the Motion Manager at the bottom of the screen. If you want to make your study even more realistic, you can add bushings to your joints. Bushings make the model more flexible by adding deformation in certain directions that would occur realistically. To add a bushing, edit one of the mates that connects to the arm of the mainframe. Because SolidWorks Motion has been added in, there's another tab at the top of the Mate Property Manager. Click the tab called Analysis. Make sure that the joint is located in the right spot, which is identified by the dot on the screen, and if not, select the correct location. The box next to the bushing can be selected, and the data for the bushing can be added in based off the bushing that will be used. This will need to be done to all the joint locations that require bushings. Each mate will now have a bushing symbol next to it. In the upper left of the Motion Manager, select Motion Analysis from the drop-down. Next, add gravity to the study by selecting the green apple and specifying the direction of gravity in the Property Manager. To simulate the shock absorber, we will add a spring and damper to the study. Click the spring icon located at the top of the Motion Manager. Select the two circular edges that are on either side of the spring. Add the spring constant, which in this case is 22 newtons per millimeter, and then the free length, which in this case is about 103 millimeters. By clicking the box next to the damper, you can add the damping constant associated with your shock absorber, which in this example is 0.46 newtons per millimeter per second. The values under display can be changed as well so that the simulated spring looks more realistic. To simulate the tire hitting a hole, a linear motor can be added by selecting the yellow motor icon at the top of the Motion Manager. Linear motor can be selected, and then the motor location and direction can be chosen. In this case, the bottom flat face of the upright was picked because it was an easy reference face to choose. Under Motion, Distance was selected from the drop-down. The height of the displacement, as well as the start time and duration, were entered into their appropriate spots. With the motor created, the key points can be edited so that the motor is only on during the time that it displaces. If it is on after that time, it will hold the position and not let the spring work correctly. The study now can be run by selecting the icon to the right of where it says Motion Analysis on the Motion Manager. At this point, the study will most likely not calculate. This is probably because there are redundancies in the assembly. By scrolling down to the Mates folder in the Motion Manager, you can see how many redundancies are in your model. Right-click the folder and select Degrees of Freedom. Here, the redundancies can be seen. Go back to the model by selecting the tab at the bottom left of the SolidWorks window. Simplify your mates so that there are no redundancies when you run the study. This may take some time as you can't have multiple mates that remove the same degree of freedom from a joint. Once there are no redundancies, the study should run as expected. For help on removing redundancies, please refer to part 1 of this video. The third and last part will cover the post-processing of the study.